Tonight we are going to visit the cold half of the solar system. Everything past the middle of the asteroid belt is far enough from the Sun that water does not stay liquid on the surface of anything. It freezes, and then it stays frozen for the age of the solar system. That sounds like an ending. It is not. It is the most common building material out there. There is more liquid water inside a small moon of Jupiter than there is in every ocean on Earth. There is a moon of Saturn that is quietly spraying itself into space and building a ring out of the spray. There is a world with rivers and lakes and rain where the rain is not water and the ground the rivers cut through is ice as hard as granite. We have been to all of them. Not with people. With machines that flew for 7, 9, 12 years to get there, and in one case flew through a fountain and tasted it. 14 things, told slowly, from the near ice to the far ice and back again. Where the evidence is thin, we will say so. Nothing to work out and nothing to wait for. If you fall asleep before the end, that is fine. Out there, ice is rock. The first thing to change is the word. Ice on Earth is a soft, temporary material. It sits a few degrees below freezing, it creeps, it melts in your hand, and it never lasts long. That is not because of what ice is. It is because of where we keep it. Our ice is always close to its melting point. Move it out to Jupiter. There, the surface of a moon sits at about 110 Kelvin, which is around 160 degrees Celsius below zero. Water ice at that temperature is not slushy or soft. It is a rigid solid with the strength of rock. You could quarry it, you could build with it. Meteors strike it and leave craters with sharp rims that stay sharp, the way they would in stone. This single fact rearranges the outer solar system in your head. Those moons are not snowballs. They are worlds with crusts, and the crust happens to be made of frozen water rather than silicate rock. Mountains stand on them. Cliffs hold. Faults open and stay open, and underneath, where pressure and heat rise with depth, the same material behaves the way rock does deep inside the Earth. It flows, slowly, over thousands of years, without melting. Glacier physics and mantle physics are the same physics with different numbers. So when we say a moon is made of ice, we are not describing something fragile, we are describing bedrock that happens to be water. The giants are big because ice was lying around. In the young solar system, there was a line, and everything about the planets follows from which side of it they formed on. Close to the Sun, it was warm enough that water existed only as vapor. Solid material there was metal and rock, and there was not very much of it. That is the inner solar system, and everything in it is small. 4 rocky planets, and if you added all 4 together, they would still be a rounding error next to Jupiter. Past a certain distance, water froze. Astronomers call that boundary the frost line or the snow line, and its position in the early solar system is usually placed somewhere near the outer asteroid belt, though the number moved as the young sun changed. Beyond it, ice was suddenly available as a solid, and there is far more water in the universe than there is rock. Bodies growing out there had several times more material to sweep up. They grew fast, and once a growing body got large enough, it could hold on to hydrogen and helium gas as well, and then it grew enormously. That is the standard account of why the outer planets are giants and the inner ones are not. It also explains the moons. A giant planet forming out there was surrounded by its own small disk of leftovers. and those leftovers were mostly ice. Jupiter and Saturn each ended up with a system of icy moons that looks like a solar system in miniature. So the ice is not an accident of the cold. It is the reason the big planets are big. Europa has almost no craters, and that is the evidence. Europa is slightly smaller than our own moon. Its surface is the smoothest and brightest of any solid body we know, and the most striking thing about it is what is missing. Everything in the solar system gets hit. Over 4.5 billion years, craters accumulate, and a surface that has been sitting still that long is saturated with them. Our moon is. Callisto, another moon of Jupiter, is. Europa has almost none. Counting the few that exist gives a surface age in the tens of millions of years, which is very young, and crater counting is an estimate rather than a measurement. A surface that young has to be getting remade. Something is erasing the record. What covers Europa instead of craters is lines. Long dark bands and ridges run across it for thousands of kilometers, crossing and overlapping, and in places, the crust looks broken into slabs that have shifted and rotated and then frozen back together. That is the behavior of a thin, brittle shell floating on something that moves. Ice on the sea does exactly this. The confirming evidence came from magnetism. As Jupiter's enormous magnetic field sweeps past Europa, it induces a magnetic field in the Moon, and the Galileo spacecraft measured it. To respond that way, Europa needs a layer near the surface that conducts electricity. Ice does not conduct. Salty liquid water does. So the argument runs: no craters, broken slabs, and a magnetic response that requires a conducting layer, not a photograph of an ocean. 3 separate pieces of evidence pointing the same way. The heat down there comes from being squeezed. Europa is 5 times further from the Sun than we are. Sunlight there is about 1/25th of what falls on your window. It cannot keep an ocean liquid. Something else does. Europa goes around Jupiter every 3.5 days, and its orbit is not quite a circle because the neighboring moons keep tugging it into a slight ellipse. Being sometimes nearer and sometimes further from an enormous planet means the pull across the moon changes through every orbit. The whole body is stretched and released, twice each circuit. Bend a paperclip back and forth, and the metal gets warm. That is the same physics. Internal friction turns motion into heat, and a moon flexing under Jupiter has a great deal of motion to turn. The extreme demonstration is next door. Io, the innermost large moon, is squeezed harder than anything else in the solar system, and it is the most volcanically active body we know of, with hundreds of vents resurfacing it constantly. Same mechanism, more of it. On Europa, the heating is gentler, and the result is a shell of ice with liquid under it rather than a world of lava. Estimates of how much water are wide. The usual comparison is that Europa holds about twice as much liquid water as all of Earth's oceans put together in a body a quarter of Earth's diameter. The number depends on how thick the ice shell is, and the thickness has never been measured directly. Estimates run from a few kilometers to 30. That range is the honest state of it. A moon of Saturn is spraying itself into space. Enceladus is small, 500 kilometers across, which would fit inside Spain. It is also the whitest object in the solar system, reflecting almost all the light that reaches it, which is why it is so cold. It keeps nothing. In 2005, the Cassini spacecraft found something at its south pole. 4 long, parallel fractures, warmer than the ground around them, which the mission team nicknamed the Tiger Stripes. And rising from those fractures, continuously, more than 100 jets of fine ice particles and water vapor, throwing material hundreds of kilometers above the surface. It is a small world with a fountain at one end, running all the time. Most of what goes up comes back down as snow, and the South Polar region is buried under a soft, fresh layer of it. Some of it does not come back. It escapes the Moon's very weak gravity entirely and goes into orbit around Saturn. That escaped material is a ring. Saturn's E-ring is the broad, faint outermost ring, and it is made of tiny ice grains from Enceladus. The Moon orbits inside its own spray, resupplying it constantly. If the jets stopped, the E-ring would disperse. We can therefore say something unusual. One of Saturn's rings has a known factory, and the factory is still running. A spacecraft flew through the spray and tasted it. The jets of Enceladus are the only place in the outer solar system where the inside of a world comes out to meet you. Cassini was not designed for this. It arrived at Saturn expecting rings and Titan. When the plume was found, the mission was replanned around it, and the spacecraft was sent through the spray repeatedly, at one point passing about 50 kilometers above the surface at a speed of several kilometers a second. It carried instruments that could weigh individual grains and individual molecules. Here is what came back. The plume is mostly water. There is salt in it, at concentrations similar to Earth's oceans, which says the water has been in long contact with rock. There are tiny grains of silica of a very particular size, and the way that size forms on Earth is in water hotter than about 90 degrees Celsius in contact with rock. There is methane, and there is molecular hydrogen. Hydrogen is the interesting one, because hydrogen escapes easily. Finding it means it is being made now, and the ordinary way to make it is water reacting with hot rock. So the reading is, a liquid ocean, in contact with a rocky floor, with chemistry going on at that boundary. That is as far as the evidence goes. It does not say anything about anyone living there, and the people who did the work say so plainly. What it says is that a moon 500 kilometers wide has warm water and rock touching each other. The samples are the closest thing we have to a bottle of alien seawater, and we collected them by flying through a fountain at 4 kilometers a second. Nobody knows why Enceladus is still warm. A body that small should have frozen solid long ago. Heat leaks out through the surface, and the smaller the world, the faster it leaks, because a small body has a lot of surface for the amount of interior it carries. Whatever heat Enceladus had when it formed is long gone. The heat coming out of the South Pole is being made now. Tidal flexing is the obvious answer, and it is almost certainly part of it. Enceladus is held in a slightly stretched orbit by a resonance with the larger moon Dione, in the same way Europa is held by its neighbors. But when the calculation is done for Enceladus at its present orbit, the heat it produces comes out too low by a wide margin to explain what Cassini measured. Several ideas fill the gap. The ice shell may flex more than a rigid shell would, especially if it is thin and the fractures at the pole are moving. The rocky core may be porous and soft, letting water circulate through it and dissipate energy inside. The orbit may have been more stretched in the past, and we may be seeing a warm episode that will end. They are all plausible. None of them is settled. This is a real open problem in planetary science, and it is worth naming that clearly, because a small moon that should be frozen and is not, is exactly the kind of fact that gets rounded off in the retelling. Titan is the only other place with liquid on the surface. Titan is the largest moon of Saturn and the second largest in the solar system. bigger than the planet Mercury. It is the only moon with a proper atmosphere, and that atmosphere is thick. At the surface, the pressure is about 1.5 times Earth's, and like ours, it is mostly nitrogen. Under that air, there are seas. Radar from Cassini mapped them, mostly near the North Pole, and the largest is about the size of the Caspian. They are not water. At 94 Kelvin, water is bedrock, and the substances that behave like water at that temperature are methane and ethane, which on Earth are natural gas. So Titan has a full cycle of liquid, and it works the way ours does. Methane evaporates from the seas, forms clouds, and falls as rain. It collects into rivers, and the rivers cut valleys and carry material and build deltas where they reach the sea. Radar images show branching river networks that any geologist would recognize instantly, except that the bedrock they cut is ice and the fluid is fuel. The rain is rare and heavy. Titan's drops are larger than ours and fall more slowly through the thick air, in gentle, low gravity. Away from the poles it is dry, and there are vast fields of dunes running around the equator, hundreds of kilometers long. The sand in them is not mineral sand. It is grains of solid organic material that formed high in the atmosphere, drifted down and collected. In 2005, the Huygens probe landed there, the most distant landing ever made. Its photographs show a flat plain of rounded pebbles, rounded the way river stones are rounded, sitting on ground that instruments found to be damp. On Titan, you could fly by flapping your arms. This one sounds like a joke, and it is a straightforward consequence of two numbers. Titan's surface gravity is about 1/7 of Earth's, close to our moons. Its atmosphere at the surface is about 4 times denser than the air you are breathing, because it is cold and cold gas is compact. Lift depends on the density of the air you push against. Weight depends on gravity. On Titan, the air is 4 times better at holding you up, and you weigh 1/7 as much. Put those together, and the requirement for human-powered flight drops by a factor of around 30. Engineers have run the calculation properly, and the answer is the same each time. A person, wearing a pair of wings of quite modest size, could take off and stay up by flapping. Not gliding. Flapping. Like a bird. You would need a great deal else. It is 94 Kelvin outside, and the air has no oxygen in it at all, so you would need a suit and something to breathe. But you would not need a pressure suit of the kind worn in vacuum, because the pressure outside is close to comfortable. It is the only surface in the solar system where a human being could move around in ordinary clothing, plus a coat and a mask, and it is the only one where the sky would hold you up. The ice on Titan may be volcanic, and we cannot prove it. If ice is the bedrock, then what plays the part of lava? The answer would be liquid water, possibly mixed with ammonia, rising from inside a cold world, reaching the surface, spreading out, and freezing. The name for it is cryovolcanism, and it would look like volcanism run at 200 degrees below zero, with water for magma and ice for stone. There are candidates. A few features on Titan have been proposed as ice volcanoes, one of them a domed structure with what looks like a collapsed summit and flows around it. Other icy moons have their own candidates. The trouble is that the same shapes can be made other ways. Ice flows on its own under its own weight. Material collapses. Impacts leave rings and domes. Radar gives you shape, not composition, and shape alone has not been enough to settle any single case. So the honest position is this. Cryovolcanism is expected on theoretical grounds, Several candidate features exist, and no example has been demonstrated beyond argument. The only confirmed eruptions of water into space in the outer solar system are the jets of Enceladus, and those come out of fractures rather than anything shaped like a volcano. We will find out. There is a mission on the way to Titan, and it is a machine that flies, because Titan's thick air makes flying the sensible way to travel there. A comet does not melt. A comet spends almost all of its life far from the sun as a lump of ice and dust, a few kilometers across, dark and inert. When it comes close enough, the ice does not turn to water. The pressure around it is zero, and at zero pressure, water ice does not have a liquid stage at all. It goes directly from solid to vapor. The word for that is sublimation, and it is what dry ice does on a table. The gas leaving the surface drags dust with it, and the comet grows a fuzzy head that can be larger than a planet, produced by a nucleus the size of a small city. Then there is the tail, and it points the wrong way for most people's expectations. A comet's tail does not trail behind it like smoke. It points away from the sun, always, because it is being pushed outward by sunlight and by the stream of particles coming off the sun. On the way in, the tail follows. On the way out, the comet chases its own tail, which runs ahead of it. We know the nucleus well now, because a spacecraft went and lived beside one. Rosetta escorted Comet 67P for 2 years. What it found was a body darker than coal, reflecting about 6% of the light that hits it, in 2 lobes joined at a neck, with cliffs and boulders and pits, and its density is about half that of water. If you had an ocean large enough, a comet would float in it, because most of the inside is empty space between loosely stacked grains. The thing that looks brightest in our sky is one of the darkest, emptiest objects we have ever visited. Pluto has a glacier that turns over like soup. Until 2015, Pluto was a few pixels. Then New Horizons went past at 14 kilometers a second and sent back pictures for months afterwards because the radio link was so slow. The largest feature is a smooth, pale plain, about 1,000 kilometers across, and it has no craters on it whatsoever. On a body that far out, where impacts are rarer, but 4.5 billion years is still 4.5 billion years, that means the surface is being remade continuously. It is a glacier, and it is not made of water. At Pluto's temperature, around 40 Kelvin, water is rigid rock. What is soft there is nitrogen, which on Earth we know as most of the air. On Pluto, nitrogen ice is the material that flows. The plain is divided into pale cells, 20 or 30 kilometers wide, with shallow troughs between them. That pattern is convection. Slightly warmer nitrogen ice at the bottom rises, spreads, cools, and sinks again at the edges, the way thick soup moves on a low heat. Each cell turns over on a time scale of around 500,000 years, which is why nothing survives on the surface. At the edges of the plain there are mountains, some of them 3 kilometers high. Nitrogen ice is far too weak to hold up a mountain that size, so those mountains have to be made of water ice, which at 40 Kelvin is strong enough. They appear to be blocks of water ice that have broken off the surrounding terrain and are sitting in the nitrogen, floating, because water ice is less dense than solid nitrogen. Icebergs of water floating in a sea of frozen air on a world we could not resolve at all 10 years ago. Triton goes the wrong way and is colder than anything we have measured. Neptune's largest moon orbits backwards. Every large moon in the solar system travels the same way its planet turns, because moons form from a disk that shares that spin. Triton goes the other way, and it is tilted besides. A moon cannot form like that. It has to have been captured. Triton is thought to have been an independent body from the same population as Pluto, wandering in the outer solar system, that passed too close to Neptune and was caught. Capture is a violent process, and afterwards the moon would have been heated enormously by tides, as its orbit was ground down into the neat circle it now occupies. Voyager 2 flew past in 1989 and found a young surface with few craters and a strange dimpled texture that has been compared to the skin of a melon. And it found the surface temperature about 38 Kelvin, which is 35 degrees above absolute zero and the coldest directly measured surface in the solar system. Then it found plumes, dark columns rising some 8 kilometers and blown sideways by winds in the thin nitrogen atmosphere, leaving dark streaks on the ice, all pointing the same way. The explanation offered is delicate and unresolved. Sunlight, very weak but able to pass through clear surface ice, warms a darker layer beneath. Nitrogen under that layer turns to gas, pressure builds, and eventually it breaks through and vents. A greenhouse effect operating a few centimeters below the ground, on the coldest surface we know, powered by sunlight 900 times fainter than ours. Voyager 2 saw it once, 37 years ago, and nothing has been back. There is ice on the planet closest to the Sun. Mercury has almost no atmosphere, and its day side reaches 400 degrees Celsius. It is the last place you would look for ice, and there is ice on it. The reason is geometry. Mercury's axis is almost perfectly upright, tilted by about 0.02 of a degree, which is the straightest of any planet. On Earth, the tilt is 23 degrees, and that is why we have seasons, and why sunlight reaches into the polar regions for half the year. On Mercury, it never does. At the poles, the sun stays on the horizon, and the floors of deep craters there are never touched by it at all. Not for a season. Not ever, for billions of years. Those floors sit at around minus 170 degrees Celsius, a few hundred kilometers from ground hot enough to melt lead. Radar from Earth found the first sign in 1992, bright patches at the poles that reflected radio waves the way ice does. The Messenger spacecraft, in orbit from 2011, confirmed it with several independent measurements, including a laser that found the crater floors unusually bright and a detector that found hydrogen concentrated there. Where it came from is most likely comets and small impacts delivering water over a long time, with the tiny fraction that landed in permanent shadow staying put because it had nowhere to go. There is the same arrangement at the poles of our own moon, and we told that story in the episode about the moon. On Mars, the ice is buried in the ground and at the poles, and that was the episode about Mars. The pattern holds everywhere we look. In this solar system, water is the default material, and sunlight is the exception. Ice does not survive out there because it is cold. It survives because nothing has come along to take it away. That is 14. Ice? That is bedrock. A frost line that made the giants big. A moon with no craters and an ocean underneath. Heat made by squeezing. A fountain at a south pole, building a ring. A spacecraft flying through that fountain and tasting salt and hot rock. A small world staying warm for reasons nobody has settled. Seas of methane with rivers running into them. Air thick enough to fly in. Volcanoes that may be made of water. A comet that never melts and would float. A glacier of frozen air turning over like soup, with mountains of water ice adrift in it. A captured moon going the wrong way at 38 Kelvin. And ice on Mercury. None of it is doing anything dramatic tonight. The jets are still going. The plane on Pluto is turning over at a centimeter a year. The ice in those crater floors has been sitting in the dark since before there was anything on Earth to watch it. Sleep well.